This project is about facial expression recognition. So the goal is to determine the facial expressions of faces detected in an image. Given an example image, the face in that image will be detected, and the correct facial expression will be labeled from a predefined set of facial expression labels. There are some known methods, some traditional known methods for facial expression recognition. One is using the face image texture, the other is using geometric information of the faces, and the other is active appearance models. All these methods use machine learning for classification. But for this project, the chosen method is using some geometric information of the face for training a data set. The main procedure is as follows. We first detect the faces in an image with the DLib library, and in the next step, with the help of the DLib library, again we extract some facial landmarks of the face. So each face will have 68 facial landmarks. These are points that are located on the strategic places on the face and can be used for later classifying the data and can be used for predicting the facial expressions. In the next step, the mean points of these 68 landmarks will be calculated and is considered as a reference point from now on. In the next step, the relative Cartesian coordinates with respect to the mean point is calculated for each facial landmark, and in the next step, the same is done for the polar coordinates. So the relative r, the relative distance, and the relative angle with respect to the mean point is calculated for each facial landmark. So up until now we have 4 values for each facial landmark, and for each face in total, remember that we have 68 facial landmarks. So in total, for each face we have 272 values that we can use for constructing a feature vector. So using this feature vector of 272 elements for each face, we train an SVM classifier. One problem that we should address is some faces, some images might have a little bit of head pose. To treat all the images, all the faces similarly, and to better classifying the data, we need to remove this head pose. What we do is first we calculate the angle between this vertical line and the line connecting these 4 facial landmarks on the nose, and then we rotate all of these 68 facial landmarks according to this calculated angle. This is it should be mentioned that this is done before these procedures. The data set that is used in this project is the famous Cone candidate dataset that contains face images of labels. The emotional labels are anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. To show you the dataset, some of the pictures, this is the dataset that I found online, a free version of this Cone candidate dataset that contains the pictures, images for different emotions, as you can see. So after training the dataset, I got this confusion matrix, and the accuracy, as you can see, is 93%. And these are some of the results when giving a new picture for this classifier. As you can see, it does a pretty good job at predicting the facial expression. One last thing that I want to show is this is the structure of the project, and the main code for classification, the training is done here in the main folder, main file. This landmark detector contains code for landmark detection and feature extraction. This file contains code for preparing data for training and prediction, and this is used for predicting new images. For example, if we run this, the facial expressions in a new image will be detected, will be recognized, as you can see.